In statistics, it is often useful to describe the position of a value relative to other values in a set of observations. In this lesson, you will learn to describe position using three common measures: percentiles, quartiles, and standard scores. Percentiles are values that divide a set of data into 100 equal parts. For any data set, there are 99 possible percentile values, which are denoted by P sub 1, P sub 2, P sub 3, etc., through P sub 99. P sub 1 is called the first percentile, P sub 2 is called the second percentile, and so on. Here's how to interpret percentiles. The ith percentile is a value such that I% of the observations in a data set fall at or below it. Thus, the 50th percentile would be the median, since it represents the middle value in the data set. That is, 50% of the values in the data set fall at or below the 50th percentile. Suppose you received a score of 91 on your statistics test. Does this mean you scored in the 91st percentile? Maybe, but probably not. For example, if your test score were equal or better than 75% of your classmates, your test score would be in the 75th percentile. If your test score were equal or better than 40% of your classmates, your score would be in the 40th percentile. Remember, a percentile score indicates how well you did relative to all of the other test scores. So the percentile that corresponds to your test score of 91 depends on how well your classmates performed. Suppose your test score puts you in the 80th percentile. What percentage of students had a better test score than you? Your test score in the 80th percentile means that you performed as well or better than 80% of the students who took the test. So, the remaining 20% performed better than you. Quartiles divide an ordered data set into 4 equal parts. The values that divide each part are called the first, second, and third quartiles, and they are denoted by Q1, Q2, and Q3, respectively. Note the relationship between quartiles and percentiles. The first quartile corresponds to the 25th percentile. The second quartile corresponds to the 50th percentile, which is the median. And the third quartile corresponds to the 75th percentile. Here's how to find quartiles. First, arrange the data set in numerical order. The second quartile, Q2, is the median of the entire data set. The first quartile, Q1, is the median of the data set below Q2. The third quartile, Q3, is the median of the data above Q2. So finding quartiles amounts to finding 3 medians. Let's work through an example using the 10 numbers displayed here. Step 1 is to arrange these numbers in order, from smallest to largest. Since they are already in numerical order, let's find Q2, which is the median of the entire data set. Recall that when you have an even number of values, the median is equal to the sum of the middle two values divided by 2. So in this example, the median, Q2, is equal to 35 plus 45 divided by 2, or 40. Then we find Q1, which is the median of all values below Q2. So Q1 is the median of 10, 11, 12, 23, and 35. With an odd number of scores, the median is just the middle value, which is 12. And finally, we find Q3, which is the median of all the values above Q2. So Q3 is the median of 45, 56, 67, 78, and 79, which is the middle value, 67. Now that we know the quartile values, how might we use them? Well, in a previous lesson, we defined the interquartile range as Q3 minus Q1. So we could use these quartiles to define the interquartile range for this set of data, which would be Q3 minus Q1, or 67 minus 12, which equals 55. A standard score indicates how many standard deviations an observation is from the mean. A standard score can be calculated from the following formula. Z equals X minus mu divided by sigma, where Z is the standard score, X is the value of the observation, mu is the mean of the data set, and sigma is the standard deviation of the data set. By the way, standard scores are also known as Z-scores. Throughout this tutorial, we will use the terms interchangeably. Let's compute a standard score. Suppose you received a score of 85 on your chemistry test. The mean score on the test was 80, and the standard deviation was 10. What is the Z-score equivalent of your test score? The formula for the Z-score is Z equals the raw score X minus the mean score mu, all divided by the standard deviation sigma. So to compute the Z-score, we plug our inputs into the formula, and we find that Z equals the raw score 85 minus the mean score 80 divided by the standard deviation 10, which reduces to 5 divided by 10. Thus, Z equals 0.5. In this example, a raw test score of 85 is equal to a Z-score of 0.5. Why go to all the trouble of converting raw scores into Z-scores? The reason is that Z-scores carry extra information. Because a Z-score represents the number of standard deviations from the mean, it tells you something about an observation that is not evident from the raw score alone. For example, if the Z-score equals 0, the observation is equal to the mean of the data set. If the z-score is less than 0, the observation is less than the mean. And if the z-score is greater than 0, the observation is greater than the mean. Suppose Mary receives a score of 43 on her chemistry test. The teacher says Mary's raw test score is equivalent to a z-score of 2.1. Compared to her classmates, how well did Mary do? Take a few minutes to think about it. The answer is, Mary did very well, better in fact than almost all of her classmates. Here's how you know. An average test score would be equivalent to a z-score of 0. Mary's score of 2.1 is greater than 0, so Mary did better than average. In fact, her test score was 2.1 standard deviations better than the average test score. Let's summarize. In this lesson, we covered 3 measures of position: percentiles, quartiles, and standard scores. The values that divide an ordered data set into 100 equal parts are called percentiles. The observation at the 50th percentile corresponds to the median of the data set. Quartiles divide an ordered data set into 4 equal parts. The values that divide each part are called the first, second, and third quartiles. Note the relationship between quartiles and percentiles. Q1 corresponds to the 25th percentile, Q2 to the 50th percentile, and Q3 to the 75th percentile. A standard score, or z-score, indicates how many standard deviations an observation is from the mean of the data set. A standard score can be calculated from the formula z equals x minus the mean mu, all divided by the standard deviation sigma. In future lessons, you will see that the z-score is very important. It plays a critical role in describing the margin of error, defining confidence intervals, and testing hypotheses.